Hello and welcome. Because of a video that I'm currently in the process of preparing, I've recently been thinking a lot about the conceptual distinction between inertial mass, that is the m in F equals ma, and gravitational mass, that is the m in weight equals mg. Now, suppose you have a 200 kilogram piano, not on wheels, that's in your carpeted living room, and you decide one day that you want to push your 200 kilogram piano from one corner of the living room to another. Well, you hardly need me to tell you, you're going to have to push quite hard to actually get your piano to move. Now, at some point in your physics education at school, you may well have learnt F equals ma, and you may have been under the impression, this is the physics explanation behind why it's so hard to move a really heavy object. The equation F equals ma is the equation linking forces to changes in motion, and so for my 200 kilogram piano, the m is a very large quantity, meaning that change in motion is very hard to achieve. And I fear that this might be quite a common way for students to think about the physical meaning of F equals ma. But here's an interesting thought. There's nothing stopping us from imagining a world in which Newtonian physics holds just as in our real world, except that inertial mass and gravitational mass are no longer constrained to being equal to each other or proportional to each other. And I put it to you that in such a world, if one were to do the basic calculations to gauge how difficult it will be to move the piano, it is the gravitational mass alone and not the value of the inertial mass that would feature in the calculation. And to help give a sense of this, let's think about the following little thought experiment. Suppose that in our real world, your piano is actually extremely light, not 200 kilograms, but only, say, 10 grams. But let's suppose that the piano is made of a magnetic material, and underneath your carpeted living room floor is an insanely strong magnet that's pulling down on your piano with a force of 2,000 newtons. In that case, do you think it will be easy or difficult to move the piano? So in terms of how we think about inertia and F equals ma, a much more appropriate example of how you might experience the quantity of an object's inertia in your everyday life might be something like, when you go shopping and you're pushing around your trolley on wheels, at the start of your shopping trip, it's quite easy to control the trolley, but by the end of your shopping trip, when you've put lots of things into your trolley, you may have found that it takes noticeably more effort to control the trolley. That's because of F equals ma. So then, the question I want to leave you with is, what would be a more correct physical model within the framework of Newtonian physics for why your piano is so hard to move? I mean, I'm claiming that it's to do with gravitational mass, but gravity is a force that acts vertically, not a force that tries to oppose horizontal motion. I think this is a good question to think about, particularly if you're studying upper high school level mechanics. Well, feel free to share your thoughts in the comments. Thank you very much for watching.